A very good evening to everyone. We, the team of Petroleum Engineers Association, is delighted to organize this webinar session on the theme Advanced Mud Logging Operation. We are very pleased to introduce Mr. Chanam Singh, sir, who will be our speaker for today's session. Currently, he is working as consulting well site geologist at Kane Oil and Gas, has more than 24 years of industrial experience. Previously, he was ex-operation manager at Geo Services, ex-field sub manager at Schlumberger. At this time, I would like to inform you all that there will be a Q&A session at the end of the session where you can ask your question. Now, I would like Mr. Chanam Singh sir to start the session. Thank you. So you can start, sir. I have
Hello, good evening, everyone. Uh, Thank you, Petroleum Engineers Association, for giving me the chance to interact with all the audience today on these advanced mud logging applications. For those who are joining from the east, good morning to all, sorry, from the west, good morning. I think we have around 105, 6 participants now. It's coming in, so maybe 1 minute or so. Let us just wait it. Little bit on this mud logging. We all know, and the industry, I think the students who are here, the majority of the crowd also know, or some have some idea about mud logging. But then, the mud logging has changed a lot since it was how it was years ago. So today, let me just, so we'll briefly discuss on some of the examples what the advanced mud logging applications can do it in the industry and can help the operations in optimizing, operations cost, etc. So I think, yeah. Let's go ahead. Okay, so a little bit about myself. As Nikhil has just introduced me, I'm working at the moment as a consulting well site geologist to Cairn. I work for the Halliburton as well as the Schlumberger managed IDS project. So I started with the IDS project for the same client, Cairn, and then for Halliburton. But then because of the pandemic, right now the operation is suspended from April, and let's see when it will pick up again, when it will start again. Before that, I was in a very short role in Houston, with Schlumberger. We call it Clima Analyst. So which was kind of remote drilling operations support and also analyst. I think I will just stop the video for let it flow. Okay, so yeah, before that I was field service manager in Schlumberger in Houston, and prior to that I was in KL, which is in Malaysia. And prior to that, I was the mud logging operations manager for Malaysia. That was from 2009 to 2012. And prior to that, I was the operations coordinator from 2006 to 8. This was under Geo Services. And then actually, I started my career in the industry from 1996 with Geo Services. And since then, initially, I worked nearly 2 years in India. Then I went to Oman, then Yemen, Sudan, Russia, Indonesia, and Brunei. This was the field job. After which I came to operations in the office from 2006. A little bit about my background. I did my graduation in geology from Ferguson College, Pune, in 1992, and then my MSc in petroleum technology from Warrior College in 1994. So that is little brief about myself. The next slide. Okay, so since we have some students, I think majority are students, although you are all from the petroleum industry, I'll give you a very brief on just a few lines. So what does the petroleum industry do? So we can mainly or briefly divide into, the first part is exploration and the exploitation, which which start from actually right from, submitting the bidding, the tender, and then from there the project start preparation, then the different surveys, and after the surveys, the planning of the wells by the drilling engineers, the geologists, the team getting approval, and then finally go for drilling, which can be onshore, offshore, or depending on the location of the well. So today we'll be talking some part of the drilling uh, and the associated activities. Next is the production of the oil and gas. Then after that, it is transported to the refineries, or sometimes as a crude, it is exported, and then the sales and so on, and then it goes to the finally your gas stations, or petrol pumps, or the LPGs and so on. So this is little brief just to begin with. Then what is mud logging? I think most of us know it already, but just to give very brief, since we are talking about the advanced applications, we need to know little bit basics of the mud logging. So we can roughly divide into three parts, into three categories. The first one is the data acquisition and the monitoring, which means this is, as you know, this is also called surface logging, which means that we do not put any downhole tools, or any sensors down there. All the acquisition, all the signals or the data that we get is from the surface. And then why do we call mud logging? Like there is also wireline logging. So in mud logging, we use mud, that is the drilling fluid, as a medium. It starts from like collecting the samples, where the cuttings are brought up to the surface with the help of this drilling fluid, that is mud. Then all uh, the other things, the gas is also transported, or it comes up along with the mud. Then the drilling fluid measurements of the volume, all this mud temperature is again with the help of the mud. So in brief, we use this mud as the medium for our logging. Logging means the continuous monitoring and recording of the data. Uh, After that, then the second part is the geological analysis. So this means what? So when we do formation evaluation, when we drill a well, all the cuttings from downhole, as we all know that unlike the mines, no one goes down, to drill a well, or to evaluate, or to study. So the cuttings come up there. It starts from the calculation. How do we know, what cutting is at surface? What are the requirements to do to get the right sample? And then how do we collect it? For example, we are drilling at a particular depth, and then but by the time the sample reaches surface, it takes some time, which is after the lag time. And then how do we wash it? How do we do the chemical analysis, the fluorescence test, the sample description under? So it is a very, actually it's a bit vast. So we will not be talking much of that today because of the time constraint. I will be focusing on mainly on the first part, that is on monitoring and the analysis, and then the next one is gas detection. So you know that mud logging is called the gas detection system is the heart of mud logging. In other words, the gas detection system is very important. Why it is important? It is the mud logging unit only. Is the mud logging, logging unit only, which is at the rig site, which can detect the gases like the hydrocarbons. I'll come to the little bit details of the gas in the after some slides. So, like the other services, let it be LWD or the wireline, or so nobody else can detect continuously the gas. And this gas is very important, is very important while drilling a well for safety as well as for the formation evaluation. So these are the very brief basic three things that is done by the mud logging team or the mud logging crew, in a rig site. After that is the normal, preparation of the reports, which includes like the daily time plot or the operations chart, then the ASCII files of the drilling, the gas, and then the geological report or the mud logging report. And then as well as during drilling, uh, depending on the client, normally there are the mud log. The mud log is, if there is a drilling, then the mud log has to be updated on a regular basis, and then it has to be submitted to the to the geologists, the operation geologists, and to the town. And then at the end of each well, there will be a report with different contents, like the ones which I mentioned just now, all the logs, mud log. So there will be another type of log which is called a drilling log with the drilling parameters, then gas logs, then again there are logs based on the measured depth, based on the TVD. So this is just a little bit about what we do in mud logging, especially for the ones, the students who are from non-mud logging background. And in a nutshell, what we do is, this is kind of a log that we prepare. Uh, Normally, the well site geologist will prepare. So what he does is formation evaluation. It's a kind of like a medical doctor, a medicine doctor checking a patient. Okay, he does some investigation. He talks to the patient. He asks his history. Then if there is any problem, then he sends his blood sample or some for the pathological study, the lab analysis. And then he also will tell him get the X-ray done, the ECG, whatever is required, whatever he thinks. So similarly, log or the formation for the formation evaluation is something like that. So what you see on the left side of the screen, the rig, then the different formations. So how do we know this lithology? As I have mentioned earlier, so it is the duty of the sample catcher or the mud logger in some cases to collect the sample from sectors, and then the mud logger will analyze the sample under the microscope, and then he will describe it. Okay, so the description is put in this format. It is entered in the data in the database or whatever station they call it, and then the other parameters. So these the lithology, the description are manually entered. Then there are some parameters which are recorded, okay, from the acquisition system, by the acquisition system. So those are here, and then the gas readings are plotted here. Then some other parameters from the LWD also can be incorporated. So it presents some information, the vital information, uh, and then whoever sees the formation evaluation can understand that this is the information of the well, of the formation evaluation. Like the medicine doctor, the physician, after he sees all the reports, then he will do his conclusion, and he will do it, and then he'll give the proper prescription or whatever is the next action. So it's a very nutshell. It's like this. Okay, so we will not go to the very detail. So this is just to give you an idea. This is similar one. This is an example where I was involved in from one client and from one company in Malaysia. So it's just to give you similar. Different companies may have different formats, but the important thing is like there will be some comments there on the drilling parameters, then on the surveys, on the lithologies, then where we started, the casing, and so on. These are the symbols used. So we'll not go into details. This is just an example. Another one is like I have mentioned there. This is just a in diagrams. So this is the mud logging unit. So mud logging is basically dealing with all the service hands, all the departments at the rig site. Okay, so the client representative, that is the it can be there. Usually there is a client representative there. It could be the company man, and then the geologist is there. Then town. So the rig floor guys, that is the driller, MWD, LWD, and so on. So this is all there. This is where you see it there. It's the recording of data, and that is the like the control room. You can say like this is the NASA of the rig site. Okay. So again, this is just an example of how the acquisition system is there. So many sensors are there, and then the gas data is there. The entry, the analysis entry, and then these displays are there. Then uh, import of the LW data from them, the LWD guys, and vice versa, and then finally the logs or the data can be transmitted to town. Okay. Another very important, these are still the basic duties of the mud logging crew. Okay, these are still uh, the basic. We're not going to advance yet. So every day in the morning, the mud logging crew has to send this operation chart. So these are the it is recording in real time, it is recording online, and then the crew has to monitor it very, very carefully, very, very watchful. They can set alarms like this, for example. These are the different parameters. These are with the annotation. So we'll not go to the details. And then all the comments respective there has to be put there. The next morning, whenever in the client office, when they see the report in 5 minutes, they should be able to understand what happened in the last 24 hours. It is very, very important. You can say like how many minutes did the driller take to make a connection, for example. Was there any problem, all the parameters? This is in brief, all the logs, all these non-editable chart, which is very, very important and very reliable. And still, this is the basic. So why do we think, or why do we say that mud logging is important? I'm sure, if not all of you, most of you must have seen movie Deepwater Horizon. Okay, so this incident, what happened is that uh, this was the transocean rig name, Deepwater Horizon, and it was drilling a well in Gulf of Mexico. It was in 2010 that it had a blowout. Can you imagine this? So, so this incident has changed the oil and gas regulations to a big, big uncertainty. So why, what happened? I am sure you must have read it, and you must have seen the movie also. If not, there is a full report, okay, on this one. You can download it. There's a 126 pages. So one small example which I would like to pull out from this is that in this incident, during the investigation, it was found out and concluded that there was simultaneous operations of mud transfer and operations. So at that time, at this on 28th of April, 1:28 p.m., the mud loggers, okay, told the driller that because of this, simultaneous operation, they had difficulty in monitoring the pits. So the AD, the assistant driller, told the mud logger that once the offloading of operation were ceased, a notice would be provided, which was not done actually in the latter part. So this is just an example how communication is very, very important. First of all, second thing is the very, very close monitoring. So I'm not saying that this was only the the reason, there were multiple reasons, but this was also one of the very important finding, one of the important findings, how important and how crucial it is in monitoring a well. And you know the consequences in terms of BP, transocean, and the environment and the concern to the world. So this is just to give you an example, how important is that. So now coming to the advanced application, which I said, it will be very difficult to cover all, but here I'm going to pick three cases, okay, only three cases uh, from three cases by using the advanced application, uh, how we can optimize operation, how important it is. Okay, so the first one is, sorry, I have selected an SPE case. Okay, this is SPE. So some drilling guys, they took uh, some wells in Vienna basin. This was then they did some survey. Okay, they did some studies. So what happened is that if you see the how the timeline of a well is uh, recorded. So this is the theoretical. And when we talk about lost time, there are some downtimes as we go with the operations, and there are some lost, but there are some invisible lost time. So this is invisible. So what happens is that once a well is drilled in a particular block or something, and after a few years or after down the line, some years, if the drilling engineers or the geologists want to refer a well to plan another one, they need to see uh, that data. So that data, when at that time, this was I'm talking about 2007 or so, so it was very difficult to find, and it took them, days and months and a lot of time, because it was not readily available. It was not easy to refer and was not very accurate. So this is just to give you. I will not go to the very detail. This is just to give you how is this. What is this invisible lost time? How can we rectify this? Okay, so uh, coming to that, why we say invisible time? If you see the daily drilling report or the DOR, this is from one of the rigs I have worked it. One example. So this is a real one. If you see here, starting from 2, and for those who have already worked, you know that in the IADC report, in the drilling report, the minimum time breakdown is 15 minutes. If you see here, there is nothing like 17 minutes we did the connection. There's always or we did that brake circulation, or that pumping, whatever. So there is nothing less than 15 minutes. 15 is either, so it goes to the next, which is the nearest. For example, the driller finishes an operation, let's say 10:10. He will not write 10:10. He will write 10:15 or sometimes 10 o'clock. So if you think a well, when we drill for few months, so the error will be very, very much, right? So this is one thing which is still practiced today. Then what these guys, this is the real example of the Vienna case. What they did is, from here it started this, automated operation recognition system. And I think now many of the logging companies are also have already, applied this one, implemented this. So from the signals that is from the traces, the system can identify whether it is drilling, whether it is reaming, whether it is just circulation, from the different parameters which are required to call drilling. For example, for drilling, the bit depth has to be at the bottom. So like that, we'll not go into the details. So this is how it is. It started taking into serious consideration that something has to be done so that all this will be uh, correctly recorded, and then the data will be able to be used, digitized, and used at the same time for future reference. So after that, drilling engineers prepare this at the end of the well every. So if you prepare it based on that 15 minutes, 15 minutes, how much do you think will be the accuracy of this? No doubt they are preparing it. But then what will be the accuracy of it? So if you prepare from the system generated, which many companies, some companies are doing that. I'm not saying not all, but I'm not saying that. But some companies are already doing that. So you can say the accuracy is much more in such cases if you use the traces. Of course, it has to be with good calibration. All the parameters have to be QC and so on. So benchmarking is what the guys in Vienna did it. So after that, you can check so many wells. They did it, I think, around 15, 16 wells. And then they came up with the benchmarking. Then they could do the KPI and so on. So it helps to improve the efficiency, and overall, at the end, it's cost saving. So this is one example which I wanted to give on the about this. So how automation will help rather than using the traditional way of reporting the drilling everyday report. So the second one I'm picking up is about the plot of LOT, rig of test, or the FIT, formation integrity test. I will not go into the very detail. The thing which I wanted to highlight is until today, many of the drilling supervisors, many of the drilling the company are still using this very, very old way of uh, plotting in the Excel. So you can see here how much volume has been pumped, and and then how much what was the pressure, surface pressure. So there are, I'm not saying again it is this manipulation, but there can be so many human error. So there is this is still there, which can be improved. Let's see this one. Okay, I was in this well as well as in this one. So as I have said, I am going to pick up three examples. One is from the SPE, one is from the well I work. So before the LOT, what we used to do, by the way, this was for a well in Gulf of Mexico. This was for Chevron, and I was in the Chevron office. So we used to monitor this in real time. In real time, when the operation was going on, we had 24/7 coverage. The night was, we were monitoring from our office, and during that time, we were in the Chevron Houston office. So during, as the operation was going on, and we had to submit this report within an hour. If you see the plots, there is no chance of human interference. Okay, so there is no chance of manipulation, and these are generated by the system, and we just take the picture and plot here. It is not manually entered. After the casing pressure test is done, making sure that everything is okay, then we did this LOT. Okay, so for that also we use this. One is the cementing unit pressure, and one is to the kill line, and then how we plotted again so and so, and then all the flow rate. For example, here we see some are still using it, relying it. I mean, one man of not, I shouldn't say relying it, but only one sensor, no, which is by the cementers. So the mud loggers can install it, depends on the contract. So there can be another sensor to tell what flow rate they're pumping and the pressure. Otherwise, they can get it through widths also and plot the same. So what I'm trying to say is the above plot, and then this one, the mud logging with a little more effort, the mud logging crew also can plot this. So here I'm not going to talk about the contract, but you can see the difference between in the quality of these two plots, the reliability, and different sensors. It doesn't mean that it will be the same number. For example, in this case, okay, so we recorded this 1202 psi. The company man reported 1207. It's just 5 psi different, which is okay. It does not have to be necessarily exactly same with the company man. Of course, to avoid confusion, we do not follow too many. But then whoever reads this chart, they will be able to understand that these are based on different senses probably, and then the recording. But the reliability is there. So nobody can finger in this data. So this is what I was trying to say, emphasize at the second point. how this advanced application can help in getting the real value of the LOT or the FIT when done. The third point I'm going to pick up is about the stock and drag. Okay, so while tripping, while maybe running in hole or pulling out or doing drilling, this is also one example where I was there myself. This was in one of the wells in Malaysia. Oh my God, you see the parameters that the drill is doing. He's taking so many parameters, and you can see the below. I'll show you the chart in the next slide. There are so many. So from here, what is he able to see? What does he know actually? He cannot interpret this. There's no time. He's so busy on the rig floor and so many parameters to take it. And still, this is being practiced. Okay, and the guy is, after plotting, this is one example. You get so many plots. Everything is in one. Of course, you can separate this to different operations, running in or pulling out of hole. So this is manually done by the basic mud logging crew or by the drilling or even by the company man. Now this is an automated plot which is done by an advanced system. The parameter is the same, the center, I mean the traces are the same. It's just a matter of the software application. It's just a matter of that. So which is done by some of the companies in the advance. Uh, so you can see here, for example, you can put the little and this is was one this was a trip out of hole. This was the red one is the pickup weight. This is the free rotating rate weight. I mean the weight in between, and then is the slack of weight. So before this, we will not go to the details, but the models has to be prepared. The friction factor has to be discussed. See it while running it, validate it. So with this, you will have a very good view, and then the speed is there. The best part is that no data is entered manually. That is the difference. No data is entered manually. So it gives you very good picture. And you can zoom in, out, and do a lot of analysis. For example, you see here, wherever there is a tight spot, okay, instead of saying, and practically, we have seen when we pull out, we got like 40 kilopounds. Okay, let us report only up to 30. I'm just maybe I'm saying too much, but this is the reality is happening. So if we send a report like this, if something is wrong, when before it is too late, there is a time to look into it by the drilling guys in town. Oh, the hole is really in bad shape. Okay, so there is time to look into it. All these are possible uh, if we if we make proper use of this advanced system. The sensor, it is the same sensor which will pick the same traces or the signals, but it is the way how it is being analyzed. But the advantage, as you see, before we go into stuck up and lost the well, how many wells are still being lost because of negligence or because of lack of what close monitoring or the analysis. Some are still following the old, the cowboy style of drilling or operation. So today the technology has changed, and then it's time to we can have to look into it. But of course, there are some companies doing it by interacting with them. Many a time it goes to town only, and not many people refer the reports. Decisions are taken at the well site without much looking into it. I'm just saying an example, but this can be still improved by using this technology. Okay, so this was a very brief three cases I picked up from drilling point of view or the monitoring point of view. The first, just to sum up again, the first one was on the SPE, Society of Petroleum Engineers paper, SPE paper, where the automation of the activity, how it can help in compiling or recording or reporting the correct data for analysis, for making use into benchmarking, and for reference for the future wells to come. Uh, or to be referred later. So second one, as I said, uh, gas detection is the heart of uh, mud logging. So again, this is a very vast topic. But we will go very to the points and brief. Okay. So when we say gas, okay, normally at the rig site, we talk about three types. One is the hydrocarbons, uh, uh, which will tell us whether there is gas. With hydrocarbon, normally when we say oil and gas, we talk about hydrocarbons and oil. The second one is H2S, hydrogen sulfide, which is very, very deadly, dangerous. So, and then next one is CO2, carbon dioxide. So the second and third, this is for safety purpose. So this from drilling point of view, very, very important. And from the formation evaluation for the reservoir the first one, which is the hydrocarbon, is important. So most of the logging companies, uh, the basic system, it detects from methane to N-pentane. This is from C1 to C5. Those who are not very familiar with the chemistry, please do not break your head. There's nothing to learn by heart. It's very simple. It is just to tell you that we normally call it C1 to C5 and how the gas is there, what components. You do not really have to, uh, you know. It is good to know, but you don't have to know all the diagrams, formulas, and what you used to do in the college days. That is not required. I'll come to the other slides. Hydrogen sulfide, we talk about it. It smells like a rotten egg smell. Once I was in Sudan and we were there, I was there nearly 4 years. So we had somehow that well started giving H2S smell. So the client told us to install our company this H2S sensors, and we installed there. We used to calibrate it, and then we used to activate this. Once in a week, you have to activate this, and we used to make some good money out of our company. But finally, it was like somehow we were not very sure. It says that was due to the decomposition of the mud, particular blah blah blah. But uh, the point is, at that time, nothing was confirmed, and it had the properties of H2S, and the company didn't take any chance, so we did install in more locations than what we had before. Okay, and CO2 is every mud logging unit will have this H2S sensor by default, one inside the unit, normally one at the cell shakers, uh, one at the somewhere in the pits, and one on the rig floor or the bell nipple area. And for CO2, unless it is really a CO2 zone, mud logging unit has one inside the unit, which is connected to the gas line. Then units of measurement. Okay, so whatever we say gas here, for the like H2S is measured in ppm because it's very, very low. Like 10 ppm is already very bad. And then the total gas in percentages, or in some places it is in units and lines, and then the other smaller ones is in ppm, means parts per million. So this is very brief about the gas. But like I said, this is just another one, but you don't have to remember all this. There's no application anywhere. You just need to know from C1. When we say C1, this is CH4 actually. This is for the alkane. Okay, this is for a single bond. Okay. Methane, ethane, and propane, and then C4 is butane has iso and normal, but then the same thing is pentane, iso and normal. So all the calibration gases come with the exactly what is there, known ppm. You just have to use that one. There's nowhere you're going to describe all this. So that's easy. Another important thing is not all are fully aware of what are the gas type of gas. So it is very, very important when we drill, when the gas is produced, when it is detected, and so whatever reading is coming, we need to understand it from the plot. Of course, it is not very easy for the beginners, but then we need to understand that, because why there are some critical types which we have to be very, very careful. For example, the connection gas. Okay, so it's very important. I'll just briefly, as you can read yourself also there. Liberated gas means when we're drilling a hydrocarbon bearing formation, if there is a gas trap in that reservoir, that will be naturally liberated. That means it will come out with the cutting. So the drilling fluid or the mud will come bring it to the surface. Okay, so it will bring it to the surface, and that is how uh, that is what we call liberated. Means it is coming from with the cuttings from the virgin rock drilled. The next one is the produced gas. So when we start drilling from the neighboring or the adjacent formation still yet to be drilled, so it also can produce, that will also add to the gas that is coming out. So that is called produced gas. So liberation is by the actual drilling, produce is yet to be drilled, but it is also coming. So these two is already clear. Then next one is recycle. Recycle means the word itself is very clear. So which means it is not newly coming out from the hole. I mean from the formation. Okay, so it means, for example, you have a very high gas of in the mud. Let's say whatever 5%, 10%, and then it is in the mud. So it is not properly descended out this one through the gas out, sorry. Then in the mud has already absorbed some gas in it. So when we pump in, when we continue circulation, some part of it is already there in the mud and will come out again. So it will recycle. That is called recycle one. Then another one is contaminated. Like I said, the example from Sudan where I was there, it was because the well was idle, after logging and so on, it was idle for some days, and because of the chemicals there, probably plus with the formation, so it got reacted, and then it was giving uh, kind of contamination gas. Then next is background gas. Background gas is the baseline. So I'll show you in one slide or in one logs. So it is the baseline, means as we drill, for example, that gas, so it will not exactly just vanish, after that drilling hydrocarbon section, it will be there some gas. And that formation, it will have some. So the peaks, when we drill the new, if there is new like hydrocarbon bearing, it will be coming as liberated gas. Then the background is like the baseline. So these terms has to be very very clearly understood. And after all this is the connection gas or the trip gas. Trip gas means suppose we while drilling, we had the maximum gas around 5%, let us say, for example. Then we pull out of a hole. Then after some time we run in hole. Whatever gas was produced, that is not circulated out. So some gas is there in the mud at that depth particular. Normally it is after the cycle. So after tripping, after running in hole, when we start circulation, when the bottoms up is at the surface, so there is normally a gas peak, which is called the trip gas, which is coming after the trip, up the leg time. Sorry. And connection is when there is the formation pressure is slightly more or is more than the hydrostatic pressure. There is one signal that we have to be careful, and this is because of the also swabbing effect. So connection gas is very important that the mud logging and the geologists monitor it. If it happens, then if it goes increasing, then it is giving you some signal. Check your mud weight, check your all the ECDs and like that. So knowing all these terminals will help in managing the gas in identifying. So another very small example, not example, this is how, for example, this is your drill string, this is the hole and how it comes out. This is a very traditional way of degasser, and that not many companies are using this now. There are many disadvantages, many errors. So this is how it comes, the flow, the degas out, and then cuttings closure. I think we're running a bit short of time, so just to show you that. Another very important thing. So when we say a percentage of the gas, total gas, maybe 5%, 10%, 1%, 2%, that doesn't mean anything. So what we need to see is that from which, what all size is coming. There are many factors. One thing is, in this case, it is the same gas, but bigger size has, the same formation. Even if it is same formation, the bigger has. If more volume is drilled, more gas is liberated. It's a very simple example. Okay, so smaller hole size is the same unless the formation is changed. Then we are expecting less gas. Why? Because we are liberating or we are drilling less amount uh, of the rock cuttings, rock volume rather. So this is very important and very simple and very good example. The same amount of gas per unit of the volume of rock, but different bit size can change the total gas. As you see here, as we go from 17.5 to 6 inch, see how it comes down. Another one is the flow rate. So if you mix if you dilute rather in a more higher volume, then definitely it will be less. So increase mud flow rate decreases gas recorded. That means increase means you are diluting it with more volume. So very important thing is when you change the flow rate, when you change the ROP, which was before, another one is rate of penetration, that also will give you a change in the gas reading. So when you are interpreting the gas from the log, you shouldn't conclude that, oh, that well was so this row. So you have to look into all these factors. What was the rate of penetration? What section was it drilling? What was the ROP, the rate of penetration? And then what was the flow rate, etc. Then only you can have some correlation. Okay. This one is about on the gas only. I'm using this one. I just this is from a Schlumberger website. You can download it. Why I'm saying is when isotope logging started, I was in Malaysia, and that time it was Geo Services. So it was a very good project. It was the field trial actually. I would say I think it was in sometime 2009. It was a field trial, and it was very good. So it is published there. I will show you another one. You can have all this isotope logging. Now many companies are also doing that. Geolog is doing, and I don't know other companies, but they're doing that. What the main point, what I want to say here is that traditionally the mud logging guys used to collect the isotube gas samples. So what happens is that it was collected during some interval, or it was at the gas peaks, or as per the requirement. So for example, if you see on the left hand side, this question mark, for example, this was the depth collected, maybe 1,000 meter. Then the next one was 1,100 or 200 and so on. Then what in between? What happens? Nobody knows that, what happens. So with this isotope logging, which is continuous one, you see on the right hand side, see how it varies. The points, this was in the field trial, the isotopes were, samples were taken, isotope logging was going on, and the data was compiled later. And when the first result came, I went to see the shell geochemist guy, and he was very happy. He did not tell me all the details, but this plot, like this. So I could see that. I do not know the details. I did not know, and I cannot share also. But you see the difference. This is how we started. The advantages is that if you take the isotube samples, and from the rig side, let it be offshore or somewhere very remote region, it comes to town, and that time we used to send to US. Just imagine from a remote country sending there. By the time it is being analyzed, and then it comes back the result, the well is already done. So it was good, but this gap was filled up by this continuous isotope logging, where you get it. That time it was done by advanced system, but after that it can be done in the logging system. So these are the kind of advanced system which will help in the formation evaluation, in studying geochemical characterization, with this little bit of extra equipment and application. So this is the advantage that it gives. I'm just telling this one as an example. There are many more in terms of XRD. There are many other applications that also can help to the and add more value to the basic mud logging to give more output. So this is one example where I was there myself. This is just a summary of that. Shipment not possible, not applicable in this when we use it. But I should use it had to be time and so on. Next one is advanced gas detector. Courtesy, this is also from Amazon website, which I just downloaded. You can get it. You can also do it. What I'm trying to say here is the advanced gas system and the standard or the basic gas system. Let it be any company. So what is the difference? If we are drilling at deep water, this is a very basic though, but still I'm just trying to show you the difference. When we are drilling at deep water, okay, which is very deep, for example, Gulf of Mexico, deep well, and it's so cold, by the time the gas comes to the surface, the temperature is so low that the gas will not be able to liberate it out, properly. So you will have a false reading. Although in the formation downhole, it is there. But with this kind of advanced system, they have so many things under control, like the temperature is controlled. First of all, the gas comes in near vacuum mode of transport, unlike the standard one. Second, most important thing is the temperature is controlled. In this particular equipment they have, it is heated at 70 degrees Celsius for the water base, and oil base is 90 degrees. So, and it is constantly. So the property is kept constant. So for whatever, unlike the standard one, any company, the standard one, it doesn't work like that. Like I just mentioned, gas tank pressure is their vacuum. Then another one is yes, cycle. Then another one is the composition. The standard ones is from C1 to C5, but this is from C1 to C8. Plus, it can also the other types like H2S, and there are other more parameters. In this case, this company uses mass spectrometer, and the standard one, most of the companies use FID technology, flame ionicity. I think that's all about it. We are almost an hour now. So just to summarize again, what we did today is a little bit about the brief mud logging, the basic mud logging. What is mud logging? How is the data acquisition system? Then what is the importance of monitoring the well? Then we pick up three examples. One SPE paper on this automation, the way that drilling report is still being practiced today, and what are the chances of error that it can give for future, for future reference, for benchmarking. So the accuracy being like 15 minutes is the minimum split up, as we all know. So what can be done and to look into it so you can have the real value of the data for your analysis in the different ways. The second one we picked up is about the way talk and drag model is being, the parameters being taken in a very traditional way, manually feeding the data and then manually plotting, confusion, and the interpretation is too late. So by the time you're stuck. So like that. And then hole cleaning issues, for example, whether the hole is really clean or not, many other things. So that was the one. And the third one was, I think, on the LOT, how it is, or the FIT, how the plots are being plotted manually still, and the chances of human error, if not manipulated. So we talk about these three main concerns. There are many more like this, like the early kick detection system, the hole cleaning, the cutting flow meter, and there are many more things where the mud logging can give real value with little more addition. And then we talk about a few things about the gas panel, the advanced system, and the basic difference. So thank you all, and now I hand over to Nikhil. If you have any queries, here is my email ID, my WhatsApp, and I'm on LinkedIn as this time I'm seeing. So over to you, Nikhil.
Yeah, so we are going towards our question answer session. So our first question, Sir, what's about the reliability of the sensors issue?
Okay. So it is very good. So when we talk about this, there has to be. It is understood that the sensor has to be reliable one, and it has to be calibrated, and it has to be verified. It's a very basic thing. It's a very basic thing. It's like, you are given a good brand car, but then if you do not check the basic things and you drive on that, so the sensor, this is understood that it has to be properly checked, calibrated. Did I answer you correct?
Yes, sir. Our next question, sir.
Yeah.
One second. Sir, as we call mud logging in the rig site the eyes of drilling, however, sometimes there are many sensor calibration problems, effect of vibration and environmental temperature on the sensors that provide wrong data. So, what's your view on this?
Like there are many sensors. If,
Mud
for
IP
example,
logging.
yeah. See, I will talk about that one. For example, if you talk about the pit sensor, okay, the all sonic, ultrasonic sensors. I myself work, so I know the problems. If there is a foaming, there's a problem. So, but there are other better sensors, like the Vega sensors. Very recently, I was with one company when I work in a well site as a well site geologist recently. I was surprised. It's an Indian company. They had a very good, this Vega sensors. It never gave any spikes. I was surprised. So it depends on the type of sensor. If you're talking about this sonic sensor, okay, the pit level sensors. I was in Russia. I work in a very cold place in Karyaga, but the pit room during, it was frozen actually. Sometimes it went to minus 30, minus 40. But in the pit room, it was, steam. It became so hot. It became so hot. And then it was giving error. So we were using this ultrasonic sensor. And on another day, my trip tank sensor, it was like frozen. I didn't know what happened. So I went out. You won't believe, it took me and my mud logger took some time to unscrew that one, bring to the unit. It was so cold. When I tested inside the unit, it was working fine. Then I checked the technical specs. So it was giving minus 42 plus 60. So it was to do with that. So it depends on such kind of sensors. It has limitation, but there are sensors which works very fine, like the Vega guided radar Vega. It doesn't have problem.
Okay, sir. So, our next question, sir, little bit long. While starting running in whole casing, for example, the sensor doesn't detect the casing depth until we will have enough weight for first casing connection. The driller has to inform mud logging data engineer that a joint is run and the casing collar level is on the rotary table in order to adjust the depth value in the mud logging system. So for the first connection, we can't optimize really the connection time because sometimes there is a lack of communication between the driller and the data engineer. What's your view in this regard?
Okay. So yes, I understand this question, and I think all the mud loggers who are in this know it very well. The issue is in the system, in your mud logging system, there is a called on sleep value. That is where you tell the system that if the weight is, for example, if the weight is less than this, you understand is like on sleep. That means the bit depth will not change it. Okay. So, for example, we're drilling with 1,000 meter and the weight on the hook weight or the string weight becomes 100 kilopound. But when it is on sleep, it will come only for the top drive. So let's say it's around 40 pounds, 40 kilopound. So suddenly that 100, when it comes to less around 40, the system will think that it is on sleep and I should not change my weight on hook. Okay, my should not sorry my bit depth. So otherwise, then your depth will be totally wrong. Similarly, when I said the sleep on threshold is 40, initially the weight will be very, very low. So it is very difficult to keep it to make the system understand it. So it depends on the smartness. Means you have to manually do it, initially. So it is to do with that, very small difference in the hook load. That is the reason. So anybody who has
Okay.
worked it as a data engineer or the external mud logger, they will understand this. But don't worry, if it is from a student, not to worry, you will learn it. And this is the basic. When you tell the system you are putting a command that if it is less than this much weight, you understand it like it's threshold for the sleep, so your bit that should not change it. Yeah.
So our next question, sir, for gas detector sensors test, what's your advice in matters of interval periods?
Okay, so if you are talking about, I think they are asking about the guy is asking about the calibration. I didn't see the chat calibration. So normally the client will have its a requirement. The standard is before you start drilling, the gas panel has to be calibrated. Secondly is every this section you have to at least the calibration check. So depending on that, but the standard one would be before the start of each section, you need to calibrate and check the gas panels.
Okay, sir, our next question, how is important is NPT and ILT information to exploration company or rig company?
Uh, can you please repeat that again?
How important is NPT and ILT information to exploration company or rig company?
uh, NPT, is
Yes,
it?
sir, non-productive time.
Okay. How important is it? Is it?
Yes, sir.
See, I do not know what you mean by important. Uh, of course, all companies do not want any NPT, or service companies, or nobody wants NPT. But there are times where you cannot avoid this. So there are two things. For example, if you are running the MWLD tool, and then if it does not perform, then you have to pull out. So then the NPT, again, depending on whose fault, what fault, technical or, so it is very important, and every company wants to bring down the NPT, but there are some unavoidable, circumstances. If the proper maintenance has been done for example, any like, the mud pumps, okay, the mud pumps, they need a regular maintenance. If the drilling company did not maintain it for long, and then if there is a problem, there was some problem, the piston and all that, so NPT will be given to them. uh, so yes, nobody wants it, but sometimes, not sometimes, we'll get NPT.
Okay, sir, our next question,
Yeah.
what could be the cause of the decrease on the return mud flow?
See, you, the question is, what will be the reason for a decrease in the mud flow? Is
Yeah,
it?
cause,
Okay.
reason, yes, sir.
Okay. So there are many factors. One thing is, if you slow down the pump, definitely there will be return. So when you say the flow, I mean the return, you have to always check with the flow in, which is the pump. So while monitoring, you have to see always. You cannot conclude with one parameter. You have to see. For example, I'm pumping at 1,000 GPM and my pressure was 2,000 psi, and then my corresponding flow out or the return was like for 50%. Okay, if I maintain the same flow and then the return is coming less, that means I can see, I can think of, the first thing mud logger has to do is that he has to inform the company man, he has to inform the driller, he has to inform the company man, he has to look into it. So this is very, very important. So let me just repeat it. If you are maintaining the same flow, okay, then suddenly there is a decrease in the return. So it will take time for you to find out. It could be because of the losses, or it could be somewhere it is, it is washed out somewhere. It could be many things, not necessarily downhole. The pressure, you have to see the pressure. First thing is you inform the driller, you inform the company man. Hey driller, I'm getting so and so little. Anything, anything just to let you know, I'm also like that. So you should not conclude with one parameter. You should check it with the flow.
Okay, so our next question,
Yeah.
how do we monitor and identify the recycle gas peak or trend in the advanced gas logging system?
Identified. So very good. The gas peak. When I said about the, I did see the gas peak. There are two things. When I was with the other company, one thing they had is there was a parameter called gas at bit. This was very, very useful. So we could easily identify the connection gases and the connection gases. Sorry, the gas peaks. So there was little bit of adjustment in the software in the system. Otherwise, sometimes it can be confusing. This is the first thing. So having this advanced system, a gas bit, whatever name the companies call it, this will really help in identifying the connection gas or it is from the formation. It's very simple. What we need to plot is, I have some example, but we don't have time today. We just need to plot the flow pumps, the gas at beat, and the hook height. With this, you can easily identify it. Second thing is, in the advanced system, like the one I mentioned, there are two gas traps. One is at in and one is at out. And then these guys, they have a software. They can run the system. They know they have some factors, and they can subtract actually the recycle or in the merge system. So they can do some corrections and get the actual formation gas. So this is the big advantage. In other words, we call this one as quantitative analysis, whereas the other ones can be qualitative.
Okay, sir. Our next question.
I hope I
Sir,
answered it. Yeah.
yeah, your view, sir. How important is mud logging on MRC or ERD wells, especially in a development field? Should mud logging be used in such cases or can be eliminated?
Mud logging will see if mud logging is not there. So can that guy answer me? How will the sample be collected? Who will be recording this data? Who will be preparing the logs of the time plot? And how will this data be? It's not about whole cleaning or not. The whole process, as I mentioned, it is about real-time monitoring for the safety reason, not just not just for the hydrocarbons. There are many factors. You saw that the Well Macando movie. I mentioned about that. So what will happen to you if there's no mud logging? Who will be monitoring all this? First thing. Second thing is about ERD, old cleaning. ERD wells means for those who are not extended reachable depth, I think. So it's a very long horizontal section. The whole cleaning is very important. There are many factors in that. Sometimes you may not see the cuttings there. It is more important there. That is what my opinion. Let me just tell you, when I was in Malaysia, we were providing service for Petronas, one well. So I went as my company representative for the morning calls every day. During every day we had a call from all the service representatives came there. So we were saying we were drilling. Normally the drilling guys are after the meter is right. So they want to drill. Oh, we drill this many, and then on the surface there is no cutting. It means all is clean. Uh, but it doesn't mean that they did not know it. They knew it. That ERD, the cuttings get settled there, the BHA, and then but they were not doing what was the standard procedure of whole cleaning. At the end, we couldn't come out. We got stuck. We lost the well, and it was a very expensive well, offshore well. And after that, they call all this service company. They call me, and then to ask, can you mobilize that equipment, like the whole cleaning, when it is, and the poor pressure guys. There were no poor pressure, but just because of whole cleaning, but it was too late. It was too late. So we lost the well and we sidetracked it. So I still remember that incident. Yeah. Anything else?
I think all this for the today's session. No more questions from the participant. Mm, so I think so. Thanks all for your valuable time and cooperation to make the event successful. I, on behalf of the Petroleum Engineers Association, thanking Mr. Charam Singh sir and providing us time from his very busy schedule, thanking him for his very informative and valuable presentation. Hope all of you have enjoyed this knowledge sharing session. I am thankful to all for your active participation, and I extend my big thanks to all my team members for their extensive support. Thank you so much, sir.
Uh, Thank you, Nikhil, on behalf of this and your team in the Petroleum Engineers Association to join in your to collaborate with your institute. I'm also very happy. Uh, I'm not sure how the audience would benefit it, because I think there are, from student to someone from the industry. I'm not sure. I haven't seen the list yet. So I hope to the beginners at least it gives some idea, the inside idea, what is mud logging, and why it is important, and what are the things that mud logging does, and what are the basic, basic concept, and then how much advanced it can. Taking this opportunity, I would like to share that we are with the association, with Petroleum Engineers Association, we are thinking to have some workshop for a detailed program. It may be from 3 to 5 days. For the details, you can contact Nikhil or Petroleum Engineer Association. There, we try to cover more with examples and with more details on including geology part. Uh, yeah, that's all I want to
Thank you
say
so
from
much,
my
sir.
side.
And
And once again, thank you all the participants. Once again, thank you for your
thank
time.
you so much, sir, for your valuable time. Have a good day ahead, sir, and have a good day to every participant.
Thank
See
you all.
you,
Thank you.
sir.